Okay. Now, in this example, so there are two questions, and in both cases, our goal is to determine the voltage across the resistor between terminal A and B. So we just want to find the voltage across this resistor, and here also we want to find the voltage across this. So we want to find the voltage across the 10 ohm resistor is how much, and the voltage across the 20 ohm resistor between terminal A and B is how much. So we just want to find these two. So let's first solve this network, and then we'll go to the second one. So for the first network, let me redraw the circuit. And okay. So now, in order to find the voltage between terminal A and B, or in order to find the voltage across this 20 ohm resistor, first we need to simplify the network. Now, before we simplify the network, there is one information about R. So we're told that R is infinity. So R is infinity means this is an open circuit. So this resistor can be replaced with an open circuit. So let's do that first. So R is infinity. So we don't have any resistor there. Okay, now what do we see? It's obvious that now these two resistors are connected in series. Like, let's say this is represented by R1. So R1 is the sum of these two resistors, 10 and 10. So 10 plus 10 is 20. So we can replace these two resistors with R1. Now let's do that. So let's remove this. Oops. Let me. So this was connected to this. Yeah, so this is it. Now those two resistors, 10 ohm resistors, are replaced by R1. So let me replace that with R1. Okay. Now the 20 ohm resistor and R1, these two are connected in parallel, right? R1 is connected between B, and let me just say this is C. R1 is connected between terminal B and C, and 20 is also connected between terminal B and C. So therefore, these two are in parallel. If they are in parallel, let's say their equivalent is R2. So 1 over 20 plus 1 over R1. R1 is 20. So this will be 1 plus 1 over 20, because R1 is 20. So R2, if we solve for this, will be 10 ohm. So therefore, the parallel combination of these two will be 10 ohm. So for that, what I will do is I'll first remove the 20 ohm resistor, and I'll remove R1 and replace their combination with a new value, which is R2. Now, what do you see? R2, so this is a 1. So R2 is, so R2 is in series with, connected in series with a 10 ohm. So if you see these two, R2 and 10 ohm resistor, the same current flows through this. They're connected in series, and they have only one junction, which is C. So therefore, if I say their combination is R3, so 10 plus R2, it gives us R3. Of course, R2 is 10, 10 plus 10 is 20 ohm. So therefore, I will replace the 10 ohm resistor and R2 with now with a new value, which is R3. So this is R3. Well, let me just remove the rest values. So RC is 20. That's the only thing we need. Now it's easy to, so R3 is 20. Now it's easy to visualize. Now you see that this is a short circuit. It's a wire. So if this is point B, this is also point B. That's just a short circuit. There's no voltage drop. It's just a wire. We don't have, the resistance is 0. So if one is B, then the other one is also B. And let's say this point is X. Let me just say it. So the top point, or this point, is X. This point. So if I redraw this circuit, it is just exactly like this. So you have the 20 ohm resistor and another 20 ohm resistor. These two are in parallel. And again, the 20 and R3 are also in parallel. It is something like this. So this is A, this is 20, and this is also 20, and this is B, this is 20, and this is R3, and this is X. So this is Rx. So we are asked to find the voltage between the 20 ohm resistor. Now, if this is, since this one and this one are connected in parallel, so these two are connected in parallel, so they have the same voltage. So the voltage across V20 is, let's say that's V1. So plus minus, we have V1. So V1 is the voltage between each component. So we can say that it is 20 ohm on both sides. So they are connected in parallel. So that means we can simplify this to 20 and 20 can be replaced with, let's say, R4. And this is A. And the 20 and R3 can also be replaced with R5. And this is X. And the midpoint is B. So still we are asked the voltage between A and B. If this is V1, this is also plus minus. This is also V1. So we are asked for V1. Now how much is R4? R4 is a parallel combination of 20 and 20. So R4 is 1 over R4 is 1 over 20 plus 1 over 20. Which is actually 2 over 1 plus 1 over 20. Definitely R4 is 10 ohm. And if you follow for R5, you get the same thing. 1 over R5 equal to 1 over 20 plus 1 over R3. This will lead us, R5 will also be 10 ohm. So R4 is 10 ohm, R5 is 10 ohm. So what do we have? So the parallel combination of these two is 10 ohm. The parallel combination of these two is 10 ohm. So what we have is, we have a voltage source plus minus, which is connected to R5, which is 10 ohm. We have B here. A here, and this is R4, which is 10 ohm. And we are asked for V1. We are asked for V1. So at this point, we can use a voltage division rule to determine the voltage across terminal A and B. Don't forget that the two 20 ohm resistors were in parallel, so the voltage across the 20 ohm resistor should be the same as the voltage across their equivalent. So so we can use a voltage division rule. So V1 will be R4 divided by R4 plus R5 times the source voltage. This is V, let's say if this is Vs, the source voltage, then that is times Vs. So R4 is 10, R4 is 10, R5 is 10. So 10 plus 10 times Vs, so this will be Vs over 2 is V1. Now, how much is the source voltage? The source voltage is given us 10 volts. So Vs is 10 volt. So this is 10 volt over 2. It will be 5 volt. V1 is 5 volt, means this is 5 volt. So the voltage across the 20 ohm resistor, or this component, so the voltage across the 20 ohm across this, so the voltage across this 20 ohm resistor is 5 volt. So this 20 ohm resistor is in parallel with that one, so they both have the same voltage. So what we did is first we determined the voltage across their equivalent, and then that voltage is the same as the voltage across each component, so we determined that one. Okay, let's get back to the example. So in this case, we determine the voltage across the 20 ohm resistor, so which is 5 volt. Now, let's do this case, the second case. So again, in the second case, the same Vs is still 10 volt and R is infinity, but now we want to determine this one, the voltage across that component. So first, let's build a circuit. Okay, let me change the color. Now we can see that we have a short circuit here. This is a short circuit. So a short circuit is in parallel with this one, so we don't need to consider that. If we have two resistors in parallel and if there is a short circuit between the two, then we don't need to consider one. Let me say I have one resistor here, but on the other side I have short circuit. So when you have this, if a resistor is connected in parallel with a short circuit, you don't need to consider that. This would be just as if you have only one side, because current prefers to flow through that. So if we have a current only goes through this component. It just only goes through this component. So for that reason, we don't need to consider this 60. And also here, if you see, we have a short circuit again, right? So we don't need to consider that. So we ignore these two components. So we don't need to consider that. And okay. Now, here what we see is, of course, we're given that R is infinity, right? So we're told that R is infinity. So R is infinity means it's an open circuit. So this resistor is an open circuit. So we don't have any resistor. So this is also an open circuit. We don't have any resistance. Well, Now, so of course the circuit it's more simplified than what we were given. Now we can see that the top circuit, so the one that we have on the left hand side, it's a short circuit between these two resistors. So we have a 12 ohm resistor and another 60 ohm resistor, and these two are connected through a wire. So this is a 12, this is a 60. Now it's obvious that we don't need to consider these two because they are connected in parallel with a short circuit. So again, if there is any current prefers to go through the short circuit. So for this reason, again, this will be ignored. While the 30 ohm resistor is still there. And the bottom one is 10. Okay, now we can proceed. So let me just remove what we have on this side. And also this side. So let me just remove all this. Now, what do you see? So the 30 ohm resistor is in series. So this is just a wire. I mean, you can replace that with we can replace that with just a short wire. Now we can see that the 30 ohm resistor is in parallel. This is in parallel with 30 ohm resistor. The 30 ohm resistor is in series with a 10 ohm resistor. So these two are in series. So let's say their equivalent is R1. So that is 30 plus 10, which is 40 ohm. So that's 40 ohm. So we can replace these two with a 40 ohm resistor. Okay. So that can be replaced with a 40 ohm resistor. So this is R1. Okay. Now the 25 ohm resistor is in parallel with R1 because they're connected to two terminals. Let's say this is A and this is B. And it's obvious that 25 ohm resistor is connected between A and B, and R1 is also connected between A and B. So they are connected in parallel. Let's say that their equivalent resistance is R2. So what we have is 1 over 25 plus 1 over R1 should be equal to 1 over R2. So this is 1 over 25 plus 1 over 40. So this is if I consider their product, this is 25 times 40 is 40 plus 25. That's 1 over R2. So R2 will be 25 times 40 divided by 40 plus 25. So the product of 25 and 40 divided by, okay, 25 times 40 divided by their sum, which is 65. So this is approximately 15.38 ohm. Okay, now let me just remove this, and replace that with, of course, this is the 5. So let me replace all this with R2. With R2. So if we need, so that's the, so R2 is 15.38. Okay, so the question is, we are asked to find the voltage between A and B, which is the voltage across the 10 ohm resistor. So to determine that, what we did is first we simplified the network and replaced everything with one equivalent resistance, which is R2, which is 15.38. Now what we'll do is we'll first determine the voltage across the 15.38 ohm resistor, and that voltage should be equal to the voltage across the 25 and the 40 ohm resistor. So so the step is, so this is exactly the same as, so this is plus minus a resistor, another resistor, a resistor, and another resistor. Well, so that's what we have. So this is 5, this is 15, this is 25, and this is 40. Now, since the 25 and the 40 ohm resistor are the same, they do have the same voltage. Let's say that voltage is V1. So the voltage across the 40 ohm resistor is V1. The voltage across the 25 ohm resistor is also V1. Now their combination, since they are in parallel, the 25 and the 40 ohm resistor, their combination is R2. The voltage across R2 is also V1. Is also V1. So solving for V1 from the first circuit is the same as getting the V1 for across the 40 ohm resistor. Now that's the first step. Once we determine that, the next step will be, we'll just use the voltage division rule to determine the voltage across the 10 ohm resistor, or the voltage across A and B. So that is our next step. But before we proceed to that, let's just calculate. So R2 is 15.38. So let's calculate V1. So V1 is, using a voltage division rule, is R2, which is 15.38, over 5 plus R2 plus 15 times Vs. Well, it's given Vs in this case also is 10 ohm resistor. Okay, so this is 15.38 divided by 5 plus 15 is 20, plus R2 is 15.38 times Vs. Of course, Vs is 10. Now, if we solve for this, 15.38 divided by 35.38, so times 10. So this will give us, if you multiply everything, it will give you 4.35 approximately. So 4.35 volts. So that's V1. So V1 is the voltage across R2, which is also the voltage across the 40 ohm resistor. Now let's go to the final step. Now, if we redraw the circuit, so the 40 ohm resistor, so this is exactly the same as, well, let me just. So this is the same as having a 30 ohm resistor here and a 10 ohm resistor here. So this is a 10 ohm resistor. This is A. This is B. That's what we're given. And this is 30 ohm resistor. Now, according to this, right? According to this, the voltage across a 10 ohm and a 30 ohm resistor is V1. So there's some. Now we can use a voltage division rule to determine the voltage across A and B. So the voltage between A and B is the same as the voltage across the 10 ohm resistor, which is 10 divided by 10 plus 30 times V1. So this voltage, or the total voltage, so this is plus minus. So the total voltage between the 30 and the 10 ohm resistor will be split according to this proportion. So this is 1/4 times V1. It's approximately equal to 1.08 or 09 volts divided by 4. So yeah, 1.086. So VAB, or the voltage between A and B, is 1.086 volts. So we used a voltage division rule to determine that. So we followed step by step. So first we simplify the entire network and solve it for R2, and then we determine the voltage across R2. So that voltage is the same as the voltage across the 25 ohm resistor, and also the combination of the 30 and the 10 ohm resistor. Now, since the 30 and the 10 ohm resistor are in series, we used a second or another voltage division rule to determine the voltage between A and B. So with this, so let's see that's what we have. So we solve the voltage across the resistors connected between A and B. Now you can reconsider this, assuming, for instance, what if R is 0? What if R is 0? What if I had a short circuit here instead of an open circuit? What if I had a short circuit instead of an open circuit? You can solve the problem just by changing R from infinity to 0. So you can see a different scenario.